What if all that you understand about your much beloved reality is false? What if it's just an illusion? An illusion so grand that even the greatest of minds fail to realize it. In this video, I will take you beyond the veil. I will show you a clear picture of how even our greatest scientific theories miserably fail when faced with the wrath of reality, and how they cannot explain even 0.0001% of its true purpose. Welcome to the 13th harmony, where we cease to become humans and start becoming gods. In the dim light of the early morning, we rise from our beds, not out of enthusiasm, but out of sheer necessity. Our bodies tired and weary from the previous day's grind, dragged from one routine to another. The alarm clocks buzz not with the promise of a new day, but as a cruel reminder of another cycle of monotonous toil. We know that our efforts are contributing to a larger machine that neither we see nor we can see. Our backs bent, bodies and spirits broken, with no light at the end of the tunnel, no divine intervention. Even science, we spent so many of our precious years studying, feels eerily tasteless, feels just like a poor joke on us, mocking us, telling us this is the only reality you have got. Cope with it or get out. For you, there is no hero's arc. There is no romance but only survival. Well, if this is the much beloved reality that we grew accustomed to, then we have the right to question why it is like that. Who made it like that? Our modern hardships, to a great deal, are an outcome of the logic systems used by our forefathers. A boring system called classical logic, which doesn't include anything even closely esoteric. A system which is the favorite food of scientists and politicians alike. Developed in ancient Greece by our great old man Mr. Aristotle, it has some rules, and reality is supposed to follow them to the letter. Those rules are: law number 1, law of identity. That is, every proposition is identical to itself. That is, A is equal to A, not B or C or something. Law number 2, law of non-contradiction. That is, no proposition can be both true and false at the same time. And finally, law number 3, law of excluded middle. That is, every proposition is either true or false, with no middle ground. Nothing in between true or false, like our boring exam questions. Now, even though Aristotle was not some die-hard religious fanatic, his ideas of rigidity and rule-based teachings were absorbed quite well by most of the religions and philosophies, like water to a sponge. But why even blame Aristotle? He is, after all, a normal biological human like us. And like all biological organisms, it is programmed in his million-year-old DNA to believe in a concrete, definable, solid reality. It's good for survival. As animals, which most of us are, it's evolutionarily etched into our very subconscious background to believe in the real stuff. Like they say, it's all in the freaking genes. This genetic memory comes to the foreground even in our day-to-day happenings and washes out even the more intellectual-minded persons to behave in a more materialistic, animal kind of way. But think of it for a second. Is it really necessary that everything that looks logical, sounds logical, and is experientially correct should reflect how reality truly works? Is reality that simple? How do we know what's real? Yeah, that's the real question. How do we really know what's real? Through our eyes, which can detect a whopping 0.0035% of the total electromagnetic spectrum, or through our ears, which is like not even 0.00. I can add more zeros, 1% sensitive to the real interesting stuff. When we compare our 5 senses to, suppose, for example, an atom that vibrates at 10 raised to power 13 Hz, we realize that we are nowhere into perceiving the real stuff that makes up our life. Ignorance is a bliss, but in our case, it is our suffering. What if we try to visualize what really is happening? Well, then it will blow up the mind of even the most intellectually minded genius. And that's precisely what we are going to do. Blow your mind, that is. From the prehistoric times, many changes had happened in our way of thinking, but one thing remained always the same: our rigid viewpoint of life and its many nuances. From Aristotle to Newton, apples always fall near to its tree. That's until the birth of a little-known guy in 1879 who grew up to be an office clerk and was reborn again in 1905 with his more known special theory of relativity. That guy, that is Mr. Einstein, didn't just change the matters at hand, instead he kicked out matter altogether out of the picture and replaced it with the more elusive thing called energy. Now, a new kind of logic is thrust down the throats of hardcore materialists. That's the matter or mass, as science guys call it. It's not that solid and stuffy, but it's something totally different. His E equals to mc square, which is voted many times as the most beautiful equation of physics, is nothing but a statement that mass and energy are basically the same, like the two sides of a coin. The only difference being that now the coin needs to be tossed at a speed of c, or 186,282 miles per second. Written differently, mass is just E divided by c square, wherein this thing called c is not some real physical object, but is just a maximum speed, and neither is E, which is pure energy. So, the combination of these two non-material stubs, that is E and C, must give rise to something that is equally non-material, right? So, what is mass or materiality? Or is it just an illusion? Take a look at this picture. It's the boring old description of a hydrogen atom which we all diligently memorized in our high school for passing our equally stressful exams. An electron revolves around the nucleus consisting of a proton and a neutron. We all memorized it, got good marks and then forgot, right? But how much of it describes the real atom? The answer is not very much. First of all, this distance is like 99.99% inaccurate. This distance will at least be a couple of miles if the size of the nucleus is as big as shown here. In fact, if all the space between the nucleus of the atom and their orbiting electrons were to be removed, our bodies would be reduced to less than the size of a pinhead. When I say less, I mean much less. This means all the stuff we see lying around is made up of 99.9999% empty space. Wait, what? That means you and I are made up of mostly nothing? That's right. Secondly, this dot in the diagram that we call an electron, which rotates around the nucleus, is neither a dot nor does it rotate. It's not like some planet rotating around the sun. It's nothing like that. This stuff called an electron is a quantum object which doesn't even exist physically unless observed by someone. We will talk more about quantum objects in the next section, but for now, know that it does not rotate in the classical sense, but instead occupies certain energy levels within the atom. Unlike classical planets and stuff, it doesn't lose energy with time. It's more like a cloud of energy than an object. But then the question arises, how can a cloud be formed with only one electron, as is the case for a hydrogen atom? It must require more than such electrons, right? No, it does not. We normal folks are visualizing things based on our brain's evolutionary programming of making things simpler, but reality is anything but simple. When we are talking about objects as small as an electron, which has a size of 2.82 divided by 10 raised to power 15 zeros, classical logic completely breaks down. An electron can be in many places at once and can even interact with itself. It's everywhere and nowhere at once, and that's how it creates a cloud, even though it may be a single piece. I just remembered a verse from an ancient book from India called the Isha Upanishad, which goes like this: it moves and it moves not. It is far and it is near. It is within all this, but yet it is not. Isha Upanishad verse 5. Yeah, but what do old guys know about atoms and stuff, right? So we must focus our attention to a more easy to understand analogy. If you throw a ball between these fan blades, it will pass right through and hit the ceiling. But if the fan is rotating at full speed, the ball cannot pass through, even if there are only 3 fan blades. In essence, the blades had created a sort of cloud-like structure. An electron vibrating at 1800 miles per second will obviously have created a literal shell, just like the fan, around the nucleus. In fact, this is one of the reasons for the apparent solidity of our everyday world, even though it is filled with nothingness. But there is yet another reason for this apparently solid world, which is the Pauli's exclusion principle, which is not that easy to understand. In 1925, one of the big shots of quantum physics, Wolfgang Pauli, stated that identical particles with half-integer spins, called fermions, cannot simultaneously occupy the same quantum state. Since electrons are also fermions, so an electron from one solid object will never allow an electron from another solid object to come close to each other, and thus would form an impenetrable energy shield which in turn will give us an illusion of solidity from our viewpoint. While there is no such thing called solidity, it feels like one from our viewpoint due to the will of these electrons. Wait, will? Whose will? Yes, will. The electron's will. To understand this, think of the quantum world as more of a mind of sorts than a real physical world. In this world, there are mind codes everywhere, codes that can't be explained by classical logic. It's kinda like the base programming of our universe. And just like software code, it does not need to make sense to you. It just is that way. From these software programs, reality emerges. It is the programming of God's mind, and this program can be cracked with mind only if we can develop a new science of consciousness. While Einstein's equations made a permanent dent into the materialistic point of views, wherein time, space, and all that was near and dear to the old guys were thrown out in the dustbin, the real lightning bolt came with the advent of quantum physics, and with it came mind-like quantum logic. In the 1920s, physicists started discovering that light can behave both as a wave and a particle at the same time. In the famous double-slit experiment, when particles like electrons or photons are fired at a barrier with two parallel slits, they exhibit wave-like behavior. If no one observes which slit the particles passes through, they create an interference pattern on the screen behind the barrier, a pattern typically associated with waves overlapping and interfering with each other. This result implies that each particle somehow passes through both the slits simultaneously, existing as a wave. However, the strangeness of the experiment becomes evident when an observer or measuring device is introduced to determine which slit a particle passes through, forcing it to behave like a classical particle rather than a wave. The interference pattern disappears, and instead, two distinct bands appear on the screen, as if the particles only pass through one slit. The effect of an intelligent observer is beyond anything the classical Newtonian physics could ever explain. It is beyond their wildest fantasies. The very fact that an object can change its character when it is observed or not by a conscious eye shuts off even the big mouths of scientific sharks. It's now the realm of weird, non-material logic where anything and everything goes. This behavior is not just limited to photons of light. Scientists have performed the experiment with objects trillions of times bigger than photons, such as atoms and molecules. Going even further, this weird behavior was displayed in events at such scales that will completely blow your mind off. In a 2021 research paper titled A Double-Slit Experiment with Human Subjects by John Duffy and Ted Locke-Temezelides of University of California, the electrons are replaced with human subjects. In this experiment, participants sit in front of a screen displaying two options, similar to the double slits. Their task was to make a choice, left or right, A or B. Each choice corresponds to a measurement. In a quantum sense, it's like asking, is the person choosing left or right? The experimenter records these choices over many trials. As participants make choices, some patterns emerge, which are plotted in a graph. Astonishingly, the data exactly resembles the interference pattern seen in the particle-based double-slit experiment. Wait, what? Are our decisions influenced by quantum-like phenomena? Are our choices wave-like? But wait, how can human decisions be waves? We are macroscopic, classical beings, right? Maybe even macroscopic systems have an underlying quantum mind-like layer. Perhaps our consciousness intertwined with the physical world dances between waves and particles. Some, like Max Tegmark of MIT, argue that consciousness itself may be a quantum state of matter. In his ORCH-OR model, or Orchestrated Objective Reduction model, Tegmark speculates that microtubules inside our neurons remain in a state of quantum superposition, just like the electrons. You know, the many places at once kind of stuff. This quantum behavior gives rise to or orchestrates our thoughts. When we interact with the outside world, this quantum state of neurons collapses into classical neurons. That is, the classical neuronal functions of firing and signal transmission, leading to self-awareness and subjective experiences. He terms this process as objective reduction. In this diagram, you can see that the human mind has infinite superimposed objectives, harnessing the infinite possibilities of the quantum realm. It can feel all of the emotions of love, joy, happiness, satisfaction, anger, fear, jealousy, disgust, guilt, shame, frustration, envy, and loneliness at the same time in the quantum state. This is the state that the brain acquires during deep sleep, meditation, and mindfulness, and is also called the delta, theta, or alpha brainwave stages. Once this godlike mental state interacts with directional signals from the environment, it loses its infinite potential and decays into a single objective structure, where our thinking prowess becomes quite limited. What this means is that our intellectual powers is near limitless in its most natural form. It harnesses the infinite possibilities of the quantum realm. It's as if our intellectual abilities tap into the mind of God itself. As prominent British astrophysicist Sir Arthur Stanley Eddington rightly pointed out in his book, The Nature of the Physical World, that the stuff of our world is mind stuff, as if created with mental codes. Maybe we are gods ourselves, we just don't realize it. While the double slit experiment and observer effects are some of the weirdest things about our reality, the weirdness doesn't end here. Once trying to disprove quantum theory, Mr. Einstein accidentally proved another counterintuitive thing about our reality, that two entities can instantly communicate with each other over vast distances. He, along with his colleagues Boris Podolsky and Nathan Rosen, argued that the quantum mechanical description of the physical reality is incomplete. To prove it, they devised a thought experiment. As you all know, Einstein is famous for his thought experiments. It goes like this. Two particles, A and B, are prepared in such a way that their combined quantum state is known, but their individual states are not. When a measurement is made on particle A, its wave function collapses and we can know about its state. But according to quantum mechanics, the state of particle B should also be instantly determined at that moment, no matter how far apart both these particles are. Einstein and those guys argued that this is impossible, as signals cannot instantly travel from one place to another and are limited by the speed of light. They called it the EPR paradox, as a sure shot argument for the failure of quantum physics, but which later proved to be quantum mechanics' biggest triumph. To save their jobs, quantum physicists desperately performed experiments based on this EPR paradox. They split one high energy photon into two lower energy photons and sent them far away from each other. But miraculously and counterintuitively, when one is observed, the other is always found to be having its opposite properties. In other words, they seem to instantly communicate with each other, turning Mr. Einstein's biggest success into his biggest embarrassment. His laws of relativity, which work so well with large objects, were instantly put into dustbin for small quantum objects. Well, mathematics and human logic have their limits. No one can own the universe as their personal property. This behavior of instant communication called entanglement has now been successfully demonstrated in much larger objects than photons. Larger molecules, aluminum drums, oscillators, and computer chips were all quantum entangled till now. Large banking organizations are now using quantum cryptography to secure their data, basically making it unhackable. In quantum cryptography, financial information is encoded as entangled photons. When a hacker tries to look at someone else's data, the mere act of observation breaks the entanglement and the data is invalidated. Fascinating, isn't it? Quantum processors harnessing the power of entanglement processes information at speeds never before imagined. While we use these weird quantum things like business as usual and forget about it, these very things are very far from ordinary. These processes, if thought carefully, question our very existence of material reality. The general understanding of our universe is so ordinary that literally anyone can ring a bell and it gets shaken. One such bell was rung by John Stuart Bell, a renowned physicist from Northern Ireland. He postulated something called the Bell's theorem of interconnectedness. In 1964, while analyzing Einstein's EPR paradox, he noticed that reality doesn't behave as conventionally as was thought before. His research completely destroyed the concept of local realism. What is local realism? For millennia, people believed both logically and intuitively in this unshakable concept. In local realism, two properties, namely locality and realism, are unshakable for any reality to exist. Locality means two distant events cannot instantly influence each other. Take for example, you are calling your girlfriend over phone. For that, you first have to dial her number, which takes time. Then radio waves from your phone will connect to the nearest cell phone tower and then to the satellite to your girlfriend's cell phone. And then to speak also, sound waves from your mouth need to reach your phone's receiver. All of this takes time. Nothing is instantaneous. This experience of linear time is called locality. Realism, on the other hand, is the idea that physical properties exist independently of observation or observers. For example, the moon should exist even if no one is looking at it, right? These two ideas were the foundation stone of pre-quantum era logic, but Bell's theorem turned them over their head. He argued that for any universe to behave in accordance with local realism, some basic properties need to be satisfied. He called them Bell's inequalities. But, as seen earlier from the EPR paradox, double slit experiment and hundreds of experiments on quantum entanglement, these inequalities are violated and broken everywhere, like the violation of piracy rights by hackers. His theorem posits that the universe is fundamentally interconnected like a spider web at the deepest levels. Objects are not bound by the rules of locality and realism. They can instantly communicate with each other. And also, if there is no one to look, reality does not come into existence. So basically, both locality and realism are violated everywhere. Maybe this interconnectedness is what many people experience as synchronicities. This may be how the universe really operates. What if, instead of being just a trick of mind, these synchronicities show a deep connection between our thoughts and the way reality really behaves? In 1954, the first particle collider called Bevatron was developed at the Lawrence Berkeley National Laboratory (LBL), which accelerates protons to an energy of 6.2 giga-electron-volts. When protons coming from opposite directions collide, they break down into a variety of exotic particles. But the most fascinating thing about these collisions is that the excess energy put to accelerate these protons also gets converted into particles. I mean, just think about it. By just adding more energy, we are getting new kind of stuff. Energy that we can neither see, feel or properly explain gets converted into stuff that we can see, feel and describe. Suppose we need to create some new kind of particle called B from an existing particle called A. We just need to match the energy of B by accelerating A with an excess energy equal to the difference between the energies of A and B, and voila, particle B will be created. It might not be as simple as that, but you get the idea, right? The main thing to ponder is the fact that the boundary between non-physical energy and physical stuff becomes quite blurry in these particle colliders. By using these, physicians discovered an entire zoo of particles which goes by hard to memorize names like mesons, baryons, leptons, counts, etc. But the most exotic of them all, the superstar of this particle zoo, was discovered in 2012, the day our Earth got destroyed. Just kidding. It's called the Higgs boson. In 1964, Peter Higgs published a paper where he argued that there must be some kind of mechanism that gives mass to objects. While most people take it for granted that objects possess mass as a God-given property of nature, Nobel Prize winners like Peter Higgs tend to go a little deeper into the workings of nature. Just like Newton and his apple falling eureka moment, Higgs also had his moment and pondered about what makes one thing more massive than another. While the weight of an object depends on the force of gravity, an object on moon weighs less than on Earth, mass does not. It is the same wherever you go. It's basically the amount of matter contained inside an object. You cannot do anything about it, right? Higgs thought otherwise. In quantum field theory, every particle is an excitation of an underlying energy field. All the stuff we see lying around is just an interplay between invisible mind-like fields. So Higgs thought that the thing that gives mass to particles must also be some kind of field. A field that creates a kind of resistance to motion. After collaborating with many other like-minded scientists, he described this mathematical field as the Higgs field. And since every field has an associated excitation that manifests as particles from our point of view, he predicted the existence of something called the Higgs boson. Many years have passed since his research paper was published, but all efforts to detect this elusive particle went in vain. The high energies necessary to manifest the Higgs boson were never available until the Large Hadron Collider was constructed in 2008. Hence, in 2012, the ultimate avatar of the particle zoo came into picture. While for the hardcore physicist, its discovery was treated just as a confirmation of previously known facts, for us normal folks, our entire viewpoint of this reality was turned upside down. Here's why. The discovery of the Higgs boson meant that Higgs field must also exist, and Higgs field gives mass to particles, which means mass is not an intrinsic property of matter, as was thought for thousands of years. Mass with a capital M, which is the only thing that makes reality real, is now at the mercy of a field that is as unreal as can be possibly imagined, making all the previous scientific big shots turn their heads from their grave. In fact, what is a field? Can we touch it? Is it really something that should be the basis of our universe? Intuitively speaking, a field is like an influence of something over something. Take for example, you are sitting in the back seat of your classroom and secretly watching movies, and the teacher catches you and expels you. The mental shock that this event created will influence you for years to come, long after both you and your teacher have left the school. You will never repeat this mistake again. Even if there is no physical object holding your hands from watching movies in a classroom, the influence is so strong that you just cannot do it. It's the same with fields. They are influences, non-physical influences that we cannot perceive. Just like the classroom analogy, these influences called fields work in a dimension of reality separate from our physical one. Mathematicians call this the complex domain, but you can call it the mind-like domain. Whose mind? Maybe God's, maybe ours. Coming back to the Higgs field, if even mass is a property of mind-like fields, then what is reality, if not a construct of our mind? Let's delve deeper. Well, it's not only in the particle colliders like LHC that particles can pop up from nothingness. It happens everywhere. Virtual particles come in and out of existence all the time. This constant sea of virtual particles is called the quantum foam by renowned physicist John Archibald Wheeler. Here's what he said. No time, no space, but what creates the space-time foam? At the bottom, at the ultra-microscopic level, it is quantum mechanics with its extraordinary uncertainty principle that holds the answer to the riddle of existence. John Archibald Wheeler. Now, this quantum foam is not some mere side effects of quantum weirdness at the tiniest scales of reality. It holds mind-boggling energy. When we take into account all the quantum fields and sum them up, it comes up to a mind-boggling 10 raised to power 113 joules per cubic meter. If we compare this energy with the more conventional general relativity's 10 raised to power minus 9 joules per cubic meter, then there is a difference of 10 raised to power 122, which has more zeros than this entire paragraph. In fact, our reality harnesses 99.999% energy from these mind-like quantum fields, which are equipotent everywhere and don't diminish with time or space, unlike gravity or electromagnetic fields. This energy, which is also called zero-point energy or vacuum energy, is the very source of creation. Again, remembering the old guy's ramblings, it moves and it moves not. It is far and it is near. It is within all this and yet it is not. Isha Upanishad, verse 5. Maybe the old guy had a point after all. Whether solid or made up of energy, the debate among scientists can go on forever. But the fact remains that detectable matter doesn't matter much in the grand scheme of things. On the cosmic scale, our everyday familiar universe only accounts for 5% of the total stuff. The rest 95% is, well, nobody knows what it is. Since percentages and values don't really matter much at universal scales, we can safely assume that we are in dark about most of the stuff that makes up our reality, and hence the need to coining terms like dark matter and dark energy. We all know that the universe is expanding, right? It is usually taught at the beginner's level of science, but that was not always the case. Before, people believed that our universe always remained in a perpetual steady state. That way of thinking was somewhat logical also, because it cannot be contracting anyway. A contracting universe wouldn't come into existence in the first place. The problem arose when Einstein, using his famous general theory of relativity, calculated that the total gravity of the universe should make it contract. Getting no plausible explanation for this contraction, he made up a mathematical trick called the cosmological constant. He argued that this constant behavior is what's preventing the universe from contracting. However, the universe doesn't like these kinds of mathematical shortcuts, and soon in the 1920s, Edwin Hubble discovered that instead of holding still, the universe is in fact expanding. In his own words, Einstein called this the biggest blunder of his life. Blunder or not, how can we explain this expansion? When the greatest theory of all time fails, what to do next? We can't do anything but acknowledge the fact that we don't know anything about the universe at all. We are literally in the darkness about the majority of this reality. Hence, in 1998, Adam Turner coined the term dark energy to account for this expansion. Then, in the same year, the Supernova Cosmology Project and the High Z Supernova Search Team found out that not only the universe is expanding, but it is doing so at an accelerated rate. This again came as a mathematical shock to the general relativity guys because it should be slowing down due to the effect of gravity. Now, unable to bear the truth, the entire burden of responsibility was put on the shoulders of this new guy called dark energy, which we neither understand nor can detect. The side effect of these mathematical shortcuts is that now nearly 70% of this reality is unknown to us and is supposed to be filled with this dark energy. But the darkness doesn't end here. If there is darkness in energy, there must be darkness in matter also, right? In 1933, Swiss-American astronomer Fritz Zwicky noticed something peculiar in the Coma cluster of galaxies. The mass of all the stars in the cluster accounted for only about 1% of the total mass needed to prevent the galaxies from escaping into outer space. Defying logic, the orbital velocities of stars remained constant or even increased with distance from the center. Trust me, this is a big revelation. Let me explain. In every galaxy, the most massive part is supposed to be its center, consisting of supermassive black holes. Because of this enormous mass, gravity is also supposed to be maximum at the center. Gravity bends the space-time fabric like a rock on a piece of cloth. Our space-time is basically curved like a hyperbola. So the velocity at the start of the path v1 should always be less than that at the end of its path v2. But this is not what's being observed. Sometimes v1 is equal to v2 and sometimes v1 is greater than v2. This weird behavior is only possible if something much more massive than the galactic center is present around the edge of the galaxy. It's like something is holding the stars in place, in orbit, to not get engulfed by the central demon. But for what? Maybe to allow life to evolve in those star systems. This godly thing that is holding the stars in exactly the precise orbits for life to evolve is nevertheless given a very bad name, that is dark matter. Now remember one thing, both this dark matter and dark energy, which together occupy 95% of our universe, are just mathematical shortcuts devised by triple PhD holders to avoid the pain of saying we don't know anything about the universe. All our theories can't explain it. But these very unknown things make our reality exist. Life exists because of them. Without the expansive anti-gravity-like tendency of dark energy and the godlike holding hands of dark matter, nothing of value could have ever existed. How much mathematical jargon will be created before humanity finally realizes that both at the smallest level and at the cosmic scales, consciousness creates conditions necessary for generating Goldilocks zones everywhere. Unexplainable mind codes working in the dark, making life exist. Whose mind? Maybe ours, maybe God's. Even if one day we know all about our universe of dark matter and dark energy, it will still mean nothing, as our universe is not even a drop in the ocean of stuff that makes our reality. As told earlier, the quantum mechanics' prediction of 10 to the power 113 joules per meter cube of energy is nowhere to be seen in our universe, and neither is the full force of gravity. Gravity is 10 raised to power 38 times weaker than the strong nuclear force. It is 10 raised to power 36 times weaker than the electromagnetic force and 10 raised to power 25 times than the weak nuclear force. If all the forces separated at almost the same time after Big Bang, then why is this injustice to gravity? Why is it so weak? It may be that the 10 raised to power 113 joules per meter cube of energy and the gravitational force is hidden not in our universe but inside other unseen worlds, maybe inside two-dimensional worlds. Wait, what? How can three-dimensional forces be hidden inside two-dimensional worlds? As counterintuitive as it may sound, this can happen. At least mathematically it can. In 1993, Nobel Prize winner Gerhard T. Hooft showed that the information contained within a volume of space can be represented on a two-dimensional surface, just like a hologram. Maybe our entire universe is a holographic projection of some other deeper reality. When we apply holographic mathematics to our much beloved laws of physics, an entirely new world emerges, the world of strings. Strings, as described by physicists, are nothing more than two-dimensional shapes similar to circles and triangles. As per string theorists, our very familiar 3D universe is just the boundary where two strings meet. In strings theory, our universe is a D3 brane world. The D stands for Dirichlet boundary conditions and the 3 denotes 3D space. As you can see, our universe is just the surface of a much larger 2D energy world. It is not even a drop compared to the real universe, which is made of pure mind stuff. In that real universe, everything is different from ours. Time and space don't matter much there. All events are instantaneous like thoughts. It is as if these abstract mathematical entities called strings are the background deep code running inside a multiversal operating system. Yet the maths is such that if those strings are not attached to our reality, we cease to exist. We get all our energy from them. They are the bulk, we are just the surface. All the above facts, if not proven, then at the very least point to the existence of deeper unknown truths about our much beloved reality. It's deep if you think as a rational scientist, but quite simple if you open your mind's eyes. It is quite simple if you access the deep layers of your subconscious. If we as humans are to take the quantum leap into near impossible technological superiority, to move out of a mere type 0 civilization, then we have to develop a new kind of science. A science of consciousness. A science that not only understands reality's mind codes, but also manipulates it to its will. Then nothing will remain impossible for us. Then there will be no suffering, no hunger, no wars, and most of all, no death. Immortality, the most impossible of them all, will be in our grasp once we acquire the knowledge of the deep layers of consciousness. That kind of science will not just evolve us, it will do so in the right way. Instead of a race to supremacy, it will be a race to happiness and progress, where instead of memorizing knowledge, we will live the knowledge, we will love the knowledge. We will finally take our place among the stars that gave birth to us. We will shine like them. Science of the physical world and that of consciousness will gently merge into one true science of everything. That will be the zenith when we finally cease to become humans and start becoming gods. Peace and progress to all. Signing out.